Okay, so this is Algebra 1, Lesson 3.7. We're looking at solving absolute value inequalities. So let's do our warm-up first, okay? So we're going to, for this one, we're going to subtract 7 from both sides. So then we get x is less than -3 because 4 minus 7 is -3. We're going to have an open circle at -3, and x is everything less than -3, so it's everything to the left. Okay, for number 2, we need to divide both sides by 14. Then x is greater than or equal to 2. So I'm going to have a closed circle at 2 since it's a greater than or equal then. And then it says everything is greater, so it's everything to the right. It's a little arrow there. Okay, for this next one, I need to move the 5 over. So 2x is greater than -4 because 1 minus 5 is -4. Divide both sides by 2. I do not flip the sign because I'm dividing by a positive number. So then x is greater than -2. I have an open circle at -2, and I color everything to the right of my -2. So we're going to look at solving compound inequalities that have one variable but an absolute value expression in them. Okay, when we write an inequality that has an absolute value, it can be written like a compound inequality. So that's what we did last lesson where we had the and or the or. So for example, the inequality, absolute value of x is less than 5. It tells all the real numbers whose distance from 0 is less than 5 units. The solutions are all the numbers between -5 and 5. So I think it's easier if I show you this on the line. So they're saying anything that I plug in to negative or into x, if I take the absolute value of it, it has to be less than 5. So for example, if I plugged in -3 into x and I took the absolute value of it, that is indeed less than 5. It can't go past -5. For example, if I put in -6 into here, the absolute value of it would come out to be 6, and that's not less than 5. So that's why we have to stop at -5, and we can go all the way up to 5. So it's everything in between. So this is an and where we have an intersection. Okay, so for our and inequalities, it's saying that the absolute value of the variable is less than some other side. Okay, so for example, I just said x, we can write it as -5 is less than x, which is less than 5, or we can say it as two inequalities. We can say x is greater than -5 and x is less than 5. If I have my or inequalities, this is when it says the inequality of the absolute value of x is greater than some number a, where a has to be something bigger than 0. They're saying what values of x have an absolute value greater than a. And the solutions are any numbers that are less than a or greater than, or less than -a and greater than +a. So this is where we would have that union where we have things that are separate on one side and things that are separate on the other side. So let's think about this. For example, if I have x, the absolute value of x is greater than 5, okay? I can write that as two inequalities with an or. X is less than -5 or x is greater than -5. For example, x is less than -5. So if I put in -6, -7, -8, anything less than -5, remember on the negative side they get bigger. If I put that in like -7, the absolute value of -7 comes out to just 7, which if we check, 7 is bigger than 5. The other side of it says x has to be something bigger than +5. So that can be 6, 7, 8. So if I put in 6, 7, 8, 9, anything in here, that will in fact be bigger than 5. So those are our or absolute values. The inequality, the absolute value of x is greater than 5. It tells of all the real numbers whose distance from 0 is greater than 5 units. The solutions are all the numbers less than -5 or, that was an or one, greater than 5, okay? So there's two different absolute value inequalities here. We have, when it's written with the absolute value is greater or greater than or equal to, we think of it as great or. So it's going to be an or, okay? When you see that the absolute value that's isolated is less than or equal to, that's when we think less than, less, and. So that's our memory aid to figure out which type it is. So this is a lot easier, I think, if I show you an example, okay? Okay, remember though, before we get started, we always have to isolate the absolute value. Then step 2, determine if it's an and or an or. And now I'm going to show you we solve two cases, just like we did in our regular absolute value equations. Okay, here's this first one. The absolute value of x minus 3 is less than negative 1. Well, we have to isolate the absolute variable first, or the absolute value first. So I need to add 3 to both sides. So the absolute value of x is less than 2. Okay, now let's look. We've isolated our absolute value, and it says that absolute value is less than 2. So remember, less than is the same as and. So this is going to be an and inequality. So now we're going to set up our two cases. So our first case is always just taking what's inside and setting it to be the same as what's up top. Our second case, we take what's in the absolute value, we flip the sign, and we set it equal to the negative of the other side. Okay, so I flipped the sign and I set it equal to the negative. Now I have two inequalities. This is an and in between, okay? Since we don't have to solve any further, we're done. You can write them like this as two separate inequalities, or you can combine them. Since it's an and, you can rewrite it like this. And then we graph it on our number line. Okay, so I'm going to have an open circle at negative 2 and an open circle at positive 2. And it says x is everything greater than negative 2, so everything this way. And it's also everything less than positive 2, so it's everything in between. So the key here was isolating first, decide if it's an and or an or. If I could spell and, that would probably help. And or. And then third, we're going to set up our two cases. Okay, so let's try another one. Okay, so I have the absolute value of x minus 1 is less than or equal to 2. Well, we have to decide, is our absolute value already isolated? Is there anything else outside of the absolute value? Well, there's not, so it's already isolated. Okay, so step 1 is done for us. Now we have to decide which way is this facing. Since it's facing away from the absolute value, we say that the absolute value is less than the other side. So this is an and inequality. Again, I can't spell and apparently. Now we set up our two cases. We take what's inside, the x minus 1. We keep the symbol the same and the other side the same. Our case 2, we take what's inside, x minus 1. We flip the sign, and now we have a negative, the less or greater than or equal to negative 2. We have our two cases. Now we have to isolate our variable in each case. So x is less than or equal to 3. I'm going to add 1 to the side. X is greater than or equal to negative 1. So this is an and. Okay. To graph it, I'm going to put 0, negative 1. Okay, let's graph our first one first. X is less than 3, less than or equal to 3. So we have a closed circle. So it's everything to the left, but I'm only going to go so far because I know this is going to have an overlap. And then my second part says x is greater than or equal to negative 1. So I have a closed circle at negative 1, and it's everything greater than or equal to. You could rewrite this as negative 1. So x is everything greater than or equal to negative 1, but less than or equal to 3. Or you can keep it as two separate inequalities as long as you know this is an and. Okay? So let's try one a little differently now. Okay, so we need to solve it. And before, our step 1 is to isolate what's in absolute value. So we've got to get rid of this 3. Well, the inverse operation is to add the 3. So then we have the absolute value of x plus 2 is greater than 8. Now, have we isolated what's in absolute value? We have. We have everything that's in absolute value by itself. Let's see if it's an and or an or. We have that the absolute value is greater, so it's a greater, so it's an or. Okay, so the stuff that's in absolute value is greater than the other side. So let's set up our two cases. Take what's inside, okay, keep it the same. And our or is x plus 2 is less than -8. So we flip the sign and then also have a negative. So now let's solve them separately. So x is greater than 6, or move my 2, x is less than -10. Now we can graph it, okay? 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Sorry, I had to go way down here. Okay. So now we know that x is everything greater than 6. Okay. So x is everything greater than 6. So I'm going to do an open circle down here at 6. It's everything greater, so it's everything that way. Or x is less than -10. So I'm going to do an open circle at -10, and then I'm going to color it this way. Okay. So I'm sorry, I made this a little squished here. So this is where, remember, my or has two separate parts of the inequality. All right, now let's see if we can write the inequality from the graph. Well, let's look at this graph. I see two separate lines, so I know that this is going to be an or. Let's do the left side first. We know that x is everything less than or equal to -6, so we have to do a less than or equal to since it's solid. And then x is everything greater or equal to 1, okay? So that's my or. And you can write those with the x on either side as long as the sign is facing the correct way. Okay, so this last one. I know that I have x is everything between -3 and +3. So I can either write it like this as two separate ones. X is greater than or equal to -3. Again, it's a solid dot, so we use greater than or equal to. And x is everything less than or equal to 3. And you can also write it combined like this if you want. So since this was a intersection, it's an and. Okay, so the big steps in all this, remember, isolate the absolute value. Step 2, determine if it's an and or an or. Okay. Step 3, set up two cases, but remember the second case, flip the sign and have a negative number on the other side. Okay. And I think when you do examples in class with me there to help, this will make more sense. So that is all.